Hello everyone. Today we will discuss AWS DynamoDB, a serverless NoSQL database, and understand how it is used to build scalable, high-performance applications. In this lecture, we will cover AWS DynamoDB, serverless NoSQL database, keys and data model, global and local secondary indexes, capacity modes and pricing, and production DynamoDB patterns. AWS DynamoDB, serverless NoSQL database. AWS DynamoDB is a fully managed NoSQL database service that removes the need for managing servers, replication, or patching. It is designed for applications that require high scalability and very low latency, typically delivering single-digit millisecond response times. DynamoDB automatically scales from zero traffic to millions of requests per second without manual intervention. It is schemaless, meaning each item in a table can have different attributes, making it flexible for evolving applications. Common use cases include session storage, job tracking, configuration management, feature flags, and event logging. Keys and data model. DynamoDB data is organized around a primary key, which is the most important part of the design. There are two types of primary keys. A simple primary key uses only a partition key, such as job ID, and uniquely identifies each item. A composite primary key uses a partition key and a sort key, such as user ID and created at. The partition key determines where the data is stored internally, while the sort key allows multiple items under the same partition to be sorted and queried efficiently. This design enables powerful query patterns like retrieving all events for a user within a time range. Proper key design is critical because it directly affects performance and prevents issues like hot partitions. Global and local secondary indexes. DynamoDB provides secondary indexes to support additional query patterns beyond the primary key. A global secondary index, GSI, allows querying data using a different partition key and optional sort key. For example, you can query all jobs based on code status instead of code job ID. GSIs are very flexible and are the most commonly used index type. A strong local secondary index, LSI, uses the same partition key but a different sort key. It must be created when the table is created and cannot be added later. GSIs and LSIs help you design multiple access patterns for the same table without duplicating data. Capacity modes and pricing. DynamoDB provides two capacity modes. On-demand mode automatically scales based on traffic and charges per request. It requires no planning and is ideal for unpredictable workloads. Provisioned mode requires you to define read and write capacity units in advance. It is more cost-efficient for steady and predictable traffic. You can also enable auto-scaling in provisioned mode to adjust capacity automatically. A common strategy is to start with on-demand during development and move to provisioned once traffic becomes stable. Production DynamoDB patterns. In production systems, DynamoDB is commonly used with specific design patterns. A session store pattern uses a session ID as the primary key, and TTL to automatically expire sessions after a set time. A job tracking pattern stores job status using a job ID, and uses a GSI on status to track and query running or pending jobs efficiently. A feature flags pattern stores configuration values that applications read on startup and cache in memory for performance optimization. TTL, time to live, is used to automatically delete expired data without manual cleanup. Point-in-time recovery, PITR, is enabled in production to protect against accidental data loss by allowing restore to any point in time. Conclusion: AWS DynamoDB is a powerful serverless NoSQL database that provides scalability, low latency, and simplicity. By properly designing keys, using indexes effectively, choosing the right capacity mode, and applying production patterns, you can build highly scalable and efficient applications. This makes DynamoDB a core component in modern serverless and cloud-native architectures. Thank you for watching.